In this video, we'll be discussing section 6.3 from chapter 6 of P3, and in this section we'll be discussing the chain rule of differentiation. Okay, so the chain rule of differentiation is often used when you have complex functions, and the complex function can be written as a chain of functions. Okay, a function of a function. So let's consider the chain rule can be expressed in two different manners. Okay, if y is a function of u and u is a function of x. Okay, if y is a function of u and u is a function of x, in that case we can, if y is a function of u and u is a function of x, y is a function of x too. Okay, if y is a function of u and u is a function of x, y is a function of x too. And if you want to find out the relationship of dy by dx, okay, we can find it by using the relationship between by using the derivatives dy by du and du by dx. Okay, so dy by dx is equal to dy by du into du by dx. Okay, if u is an intermediate function, okay, where u is a function of x and where y is a function of u. Okay, so if you have a function of a function, let's say that you have y, which is a function of x, which is again a function of x. Okay, it's a complex function. In that case, you can use this particular rule, okay, to find the derivative of the overall complex function y. Okay, now, and the other way that this function can be written as, the chain rule can be written as, is as such. Let's consider a function of a function f of gx. Okay, f of gx. So this is a function, the inner function is gx and the outer function is fx. Okay, so whenever you have the whenever you want to differentiate this function, with respect to x. Okay, first differentiate the outer function, leave the inner function as it is. Okay, in other words, let's consider the inner function as a group, leave it as it is, and differentiate the outer function. So we do f dash of simply gx. Okay, you do not do anything with the inner function. The first step is to differentiate the outer function. The second step is to multiply with the derivative of the inner function, g dash x. Alright, again, and the derivative of the outer function, leave the inner function as it is, and then multiply with the derivative of the inner function. Okay, this and this are more or less the same thing. Okay, they are expressed in different manners, but to show how this exactly works, let's consider example 6 from page 128. And in this example, we have y is equal to 3x raised to 4 plus x. Y is equal to 3x raised to 4 plus x, the whole raised to 5. And I need to find out what dy by dx is. Now, if we were doing P1 mathematics, in that case, the most the method that we use to solve this would be to expand this. Okay, and after expanding it and finding each and every term of the expansion, determining each and every term of the expansion, we would differentiate each and every term individually. Okay, but notice that the power over here is actually a very high power. Okay, it's power 5, and if you want to expand this, you'll have to use the binomial expansion, and it's going to be really complex. Okay, there is a very high chance of doing mistakes. Okay, considering that you have a high power and you need to use the binomial expansion. Okay, so while in P1 we might have expanded the entire expansion over here, in this chapter we're going to use the chain rule. Okay, there's not going to be any difference if we try to use the P1 method. If you can get the entire method done correctly, in that case you're going to get the same answer irrespective of whether you expand it and then differentiate every term individually or simply use the chain rule. In this example, you're going to use the chain rule. Okay, and to use the chain rule, let's consider two ways. We'll consider the second way as well, and consider the first way as well. For the first way, okay, we have dy by dx is equal to dy by du into du by dx. Okay, so we have y as a function of u and u as a function of x. Okay, now who's u here? Okay, in this case we are not from on first look it is not that apparent who u is. Okay, the function, if you notice, the outer function is raised to 5. Anything and the inner, there is a function inside the bracket, and that inner function is raised to 5. That is the outer function. Okay, so let's consider anything that is inside the function to be u. Okay, so let u be equal to 3x raised to 4 plus x. So if u is equal to 3x raised to 4 plus x, in that case, what is y? Y is equal to u raised to 5. Okay, so u is equal to 3x raised to 4 plus x, y is equal to u raised to 5, and thus, okay, now we want to find out dy by dx. You want to find out dy by dx, and thus we can now easily find out these two expressions. What is dy by du? Okay, y is equal to u raised to 5, dy by dx du is simply 5 into u raised to 4. Okay, this is regular P1 mathematics. Okay, dy by dx is equal to 5 into u raised to 4. Now let's talk about du by dx. Okay, what is u though? U is equal to 3x raised to 4 plus x. Therefore, du by dx is going to be equal to 3x cubed plus 1. 3x cubed plus 1. Now the final answer that you want is dy by dx. Therefore, dy by dx is equal to dy by du into du by dx, which is equal to dy by du is 5 u raised to 4, and this is 3x cubed plus 1, and this is the answer. But notice that we do have a u in the answer, but our question did not have u. We used u just to help us find the answer. So since we used u just to help us find the answer and the question did not have u, okay, the answer should also not have u. Okay, so you need to replace u back with whatever expression it equates to. So u is equal to 3x raised to 4 plus x, so we'll replace 5 3x raised to 4 plus x raised to 4 into 3x cubed plus 1. That's the final answer. Okay, you can expand this if required, but usually if you leave it at this stage, it's going to be fine. Okay, unless the question in the examination asks you to expand this. Okay, so this is the first method. We use the chain rule over here, okay, to find this answer. Now this is also the chain rule, and using this will also give you the same answer. So let's try using this. Here we have an inner function g and an outer function f. Okay, and you're first going to differentiate the outer function, and then you're going to differentiate the inner function. Okay, so let's get back again to the question here. The question is y equals 3 into x raised to 4 plus x the whole raised to 5. The outer function is the raised to 5. Okay, so anything inside the bracket is going to be the inner function, and then anything outside the bracket, okay, is your outer function, okay, raised to 5. So let's consider, so since 3x raised to 4 plus x is the inner function, let's consider that constant. We're not going to change anything. Okay, so y is equal to 3x raised to 4 plus x the whole raised to 5. There is nothing, I've just copied the question again. Okay, therefore dy by dx is equal to, okay, 3x raised to 4 plus x, let's consider that to be the inner function g. 3x raised to 4 plus x, let's consider that the inner function g, and outside we have the raised to 5, let's consider that the outer function g. Okay, sorry, the outer function f. Okay, so if the outer function is something raised to 5, the derivative of that is going to be 5 into something raised to 4. That is your derivative of the outer function. Okay, the inner function does not change. Again, if you notice the chain rule over here, we're just differentiating the outer function and not the inner function. The inner function remains the same. So since the inner function is 3x raised to 4 plus x, that just simply gets copied over. Okay, so the inner function 3x raised to 4 plus x remains the same. We are differentiating just the outer part. So raised to 5, that becomes 5 into 3x raised to 4, 3x raised to 4 plus x raised to 4. Now the next part is to differentiate the inner function. The inner function is 3x raised to 4 plus x. Differentiating that will give you differentiating that will give you 3 into 4 x cubed plus 1. 3 into 4x cubed plus 1. 3 into 4x cubed plus 1. Okay, and thus that is going to be overall equal to 5 into 3x raised to 4 plus x the whole raised to 4 into 12x cubed plus 1. And I'm noticing that in the previous method, when you were differentiating du by dx, it is the derivative of du by dx is actually 12x cubed plus 1. So this final answer is 12x3 plus 1. Notice that in both the cases, irrespective of whether you use this, whether you use the substitution u and then use this rule, or whether you directly differentiate the outer function than the inner function, in both the cases you get the same answer. 5 into 3 x raised to 4 plus x the whole raised to 4 into 12x cubed plus 1. Okay, so both the methods of the chain, both the versions of the chain rule are acceptable, and both of them are going to give you the same answer. Okay, it's all up to you to decide whether you want to use the substitution u and then do in 2 separate steps, or try to do the entire thing in one separate step, single step. Alright, let's consider another example. In this example, we're going to do example 7 on page 129, and this is y equals sine raised to 4x. Y equals sine raised to 4x. Notice that this is a function of a function, because the inner function is sine x, the outer function is raised to 4. Okay, sine raised to 4x is the same as sine x the whole raised to 4. Okay, so the inner function is sine x, the outer function is 4. We're going to do both the methods again. The first method is using a substitution u. So the substitution u in this case is going to be the function inside the bracket. Okay, sine x. So let u equal sine x. If u equals sine x, in that case y is going to be equal to u raised to 4. Okay, if u equals sine x, y is equal to u raised to 4. Now we can differentiate both these equations, both these expressions separately. So for the first one, you get du by dx equals the derivative of sine x with respect to x, which is simply cos x. And for the second expression, you get dy by du is equal to 4u cube. Okay, so now you got dy by du and du by dx. Now finally you need to find out dy by dx. Dy by dx is simply equal to dy by du into du by dx, which is equal to dy by du into du by dx, which is equal to, substitute the values, 4u cube into cos x. Okay, now notice that our question did not have any u. We introduced u ourselves. We introduced u ourselves to help us with our differentiation, and so we need to finally replace the u back with an equivalent in x or y, because the question does not have u in it. So u is equal to sine x, so we are going to replace u with sine x over here, and this becomes 4 sine x the whole cube into cos x. Okay, 4 sine x the whole cube into cos x. You can leave the answer here, but if you want to simplify the notification, you can write it as 4 sine cube x into cos x. Alright, so this is using the substitution, using a new variable u substitution. This is that method. Okay, if you want to use the direct method where you do not introduce any new variable u, in that case, let's start again. Okay, y is equal to sine raised to 4x, which is the same as sine x the whole raised to 4. Okay, we have an outer function and an inner function. The inner function is the sine function, and the outer function is your raised to 4 function. Okay, and thus dy by dx, the inner function you are going to do no change to that. The inner function remains the same. Differentiate outside first, so the outer function gets differentiated, and that becomes 4 into something cube, where that something is simply the inner function unchanged. The inner function is sine x, so it becomes sine x, and then the next step is to multiply by differentiate the inner function. Okay, so the inner function over here is sine x, the derivative of that function is cos x. Okay, that's the second step done, and finally we can simplify this expression to 4 sine cube x cos x. Notice in both the cases you get the same answer, 4 sine cube x into cos x. Now let's consider another example. In this example we are going to consider you're going to consider y equals ln of sine x plus cos x. Okay, so here we do have two functions. We have an inner function sine x plus cos x, okay, and an outer function ln. Okay, so if we try to do the first method where we used a substitution variable u, okay, let the inner variable be u, okay, and thus u is equal to sine x plus cos x. And if u is equal to sine x plus cos x, in that case y is equal to simply ln u. Okay, so this is our variable of substitution. We are using a substitution variable u. Okay, so if u is equal to sine x plus cos x, in that case y is simply ln u. Now our differentiation is going to be easier. The first step, from the first equation, we get du by dx. Okay, we're differentiating both sides with respect to x. If you differentiate the first left side, it is going to be du by dx. The right side, you're going to differentiate sine x with respect to x, that becomes cos x. And you're differentiating cos x with respect to x, that becomes minus sine x. Make sure that you do not forget the negative sign. Okay, the pluses and the minuses are often confusing when you consider trigonometric functions and the derivatives. Sine x is cos x becomes a minus sine x. So du by dx equals cos x minus sine x. Now from this equation we get dy by du is equal to 1 by u, because that's the derivative of the ln function. Okay, the derivative of ln u with respect to u is simply 1 by u. So now that you have got the two derivatives, we can easily find the overall derivative. The overall derivative is dy by dx is equal to dy by du into du by dx. Okay, the derivative of the dy by dx is equal to dy by du into du by dx. Okay, dy by dx is equal to 1 by u. Du by d, excuse me, into du by dx is equal to cos x minus sin x. And so this is the answer, but you need to replace the u back with your original expression because u was not there in the question. Okay, as a result, this becomes cos x minus sin x divided by sin x plus cos x. That's your final answer here. Okay, now if you do want to use the other method where we do not use any substitution variable but to do the entire thing in one complete step, in that case we need to determine who the inner function is and who the outer function is. Okay, so the outer function is your f, the outer function is your ln function, the inner function is your gx function. The inner function is your sin x plus cos x function. The outer function is the ln function, the inner function is the sin x plus cos x function. Now if we do the differentiation here, okay, we are first going to differentiate the outer function, okay, and leave the inner function as it is. Okay, start from the outside and move inwards. Okay, so if you start from outside, the outer function is ln, and the derivative of that function is going to be 1 by the expression. Okay, so if it was ln x, in that case it would be 1 by x. If it was ln u, it would be 1 by u. If it was ln of x cube, it would be 1 by x cube. In this case, it is ln of sin x plus cos x. It is going to be 1 by sin x plus cos x. Okay, so that's so notice that the inner function we did not make any changes over here. We just copied it down. Okay, the outer function ln got differentiated and you got 1 by the expression inside in the logarithm in the ln function. Now the next step is to multiply the inner function, multiply the derivative of the inner function. So the derivative of the inner function is going to be sin x has derivative cos x and cos x has derivative minus sin x. Okay, that's it. We're done with the differentiation, simplifying the notification over here, notation that you are using, cos x by sin x divided by sin x plus cos x. Notice in both cases you get the same answer, cos x minus sin x divided by sin x plus cos x. Alright, now we do have, because we so the chain rule can also be used in a different manner as well. Okay, consider dy by dx equals dy by du into du by dx. Okay, So dy by dx equals dy by du into du by dx. Okay, and we are going to change this expression. Since dy by dx equals dy by du into du by dx, we can actually consider let's replace y let's replace x with y. Yeah, let's replace x with y, and let's replace u with x. Let's simply replace x with y. Okay, so if we replace x with y, you get dy by dy is equal to dy by du into du by dy. Okay, so if you simply replace x with y, we get dy by dy is equal to dy by du into du by dy, and this chain rule is still valid. Okay, replacing x with y, you get dy by dy equals dy by du into du by dy. Now notice that dy by dy over here is simply 1. Okay, the derivative of a function with respect to itself, the derivative of a variable with respect to itself, the derivative of y with respect to y is going to be simply 1. So if you simplify this expression, you get 1 is equal to dy by du into du by dy. Okay, and now if I try to move du by dy to the other side of the equation, we get dy by du is equal to 1 by du by dy. Okay, dy by du is equal to 1 by du by dy, and this is another a simpler version of the chain rule, which is often useful in a lot many cases when you're trying to do implicit differentiation. But dy by du is equal to 1 by du by dy. Now if I try to replace u with a new variable, let's consider in this case we are replacing it with x, even though we had x previously, but let's consider that u is replaced with x. In that case, you get dy by dx is equal to 1 by dx by dy. Okay, so dy by dx is equal to 1 by dx by dy, and this is another version of the chain rule. Now, where can you use this version of the chain rule? An example is given on page 130, and in this example, you are given to find the derivative of y cube. In this example, you are given to find the derivative, the dy by dx expression for y cube plus y is equal to x. Okay, for y cube of y is equal to x. Now, notice that we cannot directly find out dy by dx because we do not have y separately on one side of the equation. We have a y, we have a y cube, and thus this differentiating this equation is not as simple as the other equations that we've encountered before. In this one, we have two expressions in y and y cube, and thus we need to differentiate each of them separately. Okay, so in this case, let's consider two methods. Okay, the first method we're going to do is to differentiate both sides with respect to y. Okay, so if we differentiate both sides with respect to y, we get, okay, if we differentiate both sides with respect to y, we get y cube, the derivative with respect to of y cube with respect to y is going to be 3y squared plus the derivative of y is 1. Okay, so and the derivative of y cube with respect to y is 3y squared. The derivative of y is simply 1 with respect to y, and the derivative of x is dx by dy. Okay, and the derivative of x is dx by dy. So since the derivative of x is dx by dy, okay, now you can use the chain rule, dy by dx equals 1 by dx by dy, and we can find that dy by dx is equal to 1 by 3y squared plus 1. Okay, again once more, since dx by dy is equal to 3y squared plus 1, and from the chain rule we know that dy by dx and dx by dy are reciprocals of each other. Okay, dy by dx is equal to 1 by 3y squared plus 1. Now you might be questioning that, okay, I got dy by dx, but my final answer is not in terms of x, it is in terms of y. It does not matter. Okay, as long as you do not introduce any new variables. If you do introduce any new variables, those new variables need to be removed in the final answer. But as long as you have the original variables y and x in the final answer, it does not make a difference. So in this example, we differentiated with respect to y. Now let's consider another example. Now let's consider the second method. In this method, you're going to differentiate both sides with respect to x rather than with respect to y. So if you differentiate the first expression with respect to x, notice that this is going to require the chain rule. Okay, so we have y cube. I mean, the first part of the expression is going to be easy. Okay, because y, the derivative of y with respect to x, is simply dy by dx. Okay, that's easy. The derivative of y with respect to x is dy by dx. The derivative of x is equal to 1. Okay, again, the derivative of y with respect to x is dy by dx. The derivative of x is 1, but the derivative of y cube, okay, that one, even though the derivative of y cube with respect to x, okay, here we have a function of a function, so you're going to use the chain rule. Okay, so the inner function is going to be g, the outer function is going to be your cube function. Okay, the inner function is going to be your y actually, and the outer function is going to be your f function, okay, the cube function. So the first step is to leave the inner function as it is and differentiate the outer function. So that is going to be equal to 3 into y square. Okay, so there is no change made to y. We are differentiating the outer function f, which is cube here. Okay, so we do 3 and then y square. Okay, now the second step of the equation is the second step of the differentiation is to multiply by the derivative of the function inside the bracket. Okay, the derivative of the function in the inside bracket function is y, and the derivative of that function with respect to x is simply dy by dx. So you replace this expression here, we get 3y squared into dy by dx plus dy by dx is equal to 1. Notice that dy by dx is common in both the expressions, we can factorize it out. Okay, so if we take out dy by dx, we get in the bracket 3y squared from the first term and plus 1 from the second term. There is no coefficient to dy by dx, so it's simply 1, and this is equal to 1. And finally, if we rearrange the expression, you get dy by dx is equal to 1 divided by 3y squared plus 1. Okay, and this is the same expression that you get in the previous case. Okay, so it does not matter whether you differentiate with respect to y or differentiate with respect to x. At the end, when you try to use either the chain rule and dy by dx equals 1 by dx by dy, or the general chain rule, in both cases you're going to get the same answer. Okay, so again, just to summarize the entire procedure, the rules that you've learned in this section, if you have a function of a function, okay, you need to have a function of a function. Okay, there needs to be an inner function and there needs to be an outer function. So we have a function, an inner function and an outer function, and if we have an inner function and outer function, in that case you can use any versions of the chain rule. Okay, so dy by dx is equal to dy by du into du by dx, where u is your inner function. Okay, so dy by dx equals dy by du into du by dx, where u is your inner function. Okay, so you're going to get two separate expressions, one for y and u differentiate that to find dy by du, and the second one for u and x, differentiate that to get du by dx, and then use both of them to find this answer. And the second method is to do it without introducing any substitution variable and do it in one single step. For that, we are going to differentiate the outer function first, leave the inner function untouched, and then multiply by the derivative of the inner function. This one, the second expression doesn't have to do anything with the outer function. Now let's consider another example. In this example, you're going to have a more complex function. Let's consider y is equal to root of sine of root x. Root of sine of root x. So we have an outer function root, and then we have an inner function sine of root x. But that sine of root x is also a function of a function, because for that one we have an outer function sine and inner function root, okay, of the x. So if you try to use the substitution variable and try to do the differentiation using the substitution variable, in this case you're going to have two two-way substitutions to be made. So let's start with dy by dx. Now since we are having two chained functions, overall three functions we have here, that's why we're going to use dy by du into du by dv into dv by dx. Okay, again, okay, since this one just does not have since this one does not have just two functions but three functions, okay, chained together, we're going to have to use another stage in our chain rule formula. So in the previous cases we simply had u, we simply used the help of u. In this case we're going to have to use the help of another variable v. Okay, so dy by dx equals dy by du into du by dv into dv by dx. Okay, so let's start. If u is equal to sine root x, if u is equal to sine of root x, in that case y, if u is equal to sine root x, in that case y is equal to root of u. If u is equal to sine of root x, in that case y is root of u. So can you find the derivative of y with respect to u? Can you find dy by du? In this case, notice that you simply have y equals root u, which is a very simple expression and a very simple equation, and thus we can easily find the derivative of this one. Before you find the derivative, you need to express this as a power. So this is simply u raised to half, and once you know this, you can use p1 differentiation, and thus dy by du is equal to half into u raised to minus 3 by 2. Alright, so that part of the expression is done. Now let's come here. Okay, u equals sine root x. Okay, notice that there is a sine and there is a root x function, and we cannot differentiate both of them at the same time. There is a function of a function here involved, and so we need our second substitution variable v. So let root x be equal to v. Okay, so let v equal root x. So if v equals root x, in that case if you substitute v into this expression, you get u is equal to sine v. Okay, since v is equal to root x, substitute v into this expression, you get u is equal to sine v. Now you have simply one function in this expression, and you can easily differentiate this. So u is equal to sine v. Okay, this means du by dv is equal to cos v. Okay, so you got a second expression, you got the first already. Now finally the last expression is v equals root x. Okay, you need to differentiate this. Let's get it into the right form for differentiation, and that is going to be x raised to half, and then the rest is going to be p1 differentiation. Dv by dx is equal to half into x raised to minus 3 by 2. Alright, dv by dx is equal to half into x raised to minus 3 by 2. So once you've done it this, the rest is going to be simply plugging into the equation that you already have here. So dy by dx is equal to dy by du, which is half into u raised to minus 3 by 2, into du by dv, which is cos v, into dv by dx, which is half into x raised to minus 3 by 2. And here you have an answer. Okay, but notice that a question had simply y and x. It did not have u and v. We introduced u and v to help us find the answer, and so in the final answer we need to remove u and v because the question did not have u and v. So what is the expression for u though? The expression for u, we could use sine u. We could use this expression u equals sine v, but this actually has v in it. We need to remove v as well. Okay. This expression though, y u equals sine of root x, this one does not have any v or u, and so we can use this expression. Okay, so this becomes half into sine of root x the whole raised to minus 3 by 2. Okay, the first part is done. Second part is cos v. V needs to be removed. V is equal to root x. Okay, we know we had made this substitution earlier. So v is equal to root x. So simply substitute, get cos of root x. Okay, and finally we have got half x raised to minus 3 by 2. That part is the same. Okay, the rest is going to be simple, a simplification of the entire thing that you see over here. So that is going to become there you go. That's the final answer. Okay, so 2 and 2 come over here as 4 in the denominator. We have cos root x, that's here. We have x raised to minus 3 by 2, that becomes x cubed the whole root in the denominator, and you have sine raised to sine root x the whole raised to minus 3 by 2, which is sine cube of root x the whole root in the denominator. So that's the final answer. Okay, so this again, this was the first method. I mean, it doesn't matter which method you use, whether you want to use the substitution variable or whether you want to do the entire thing in one step, that's fine. But in this case, in this method, we try to use the substitution variable method, and this is the answer. If you want to do the entire thing in one step, in that case, we need to start again with the outer function and move on to the inner function. Okay, so let's start. Y is equal to root of sine of root x. Now let's get this function ready for differentiation, and by ready for differentiation I mean replace the roots with more standard versions that we use in differentiation. So this is going to become equal to sine of x raised to half, okay, the whole raised to half. Okay, sine of x raised to half the whole raised to half. Now it looks more ready for differentiation. So now let's consider what is the outer function. The outer function, we start differentiating from the outside. Okay, the outer function is going to be your raised to half function. That is your f function. Okay, the inner function is your sine function. Okay, that is your gx function, and then we still have another inner function. Okay, and that is going to be your hx function. All right, so if you want to differentiate the entire thing in one step, in that case you will start from differentiating the outer one, and then you start differentiating the inner one, and then in the final step you will differentiate the most inner function that is present. Okay, so the first step is to differentiate the outer function half, and that becomes half into whatever is inside raised to minus 3 by 2. So half into whatever is inside raised to minus 3 by 2. That is the derivative of the outer function. Okay, and the inner function is simply sine into sine of x raised to minus half. That simply gets copied down. Okay, nothing changes there. So the outer function derivative is half into everything inside the bracket raised to minus 3 by 2. Now the second step is to differentiate the inner function. Okay, as usual, the second step is to differentiate the inner function. Okay, So if you want to differentiate this function, note that there is a function of a function inside. So we're going to do the same thing again. We're going to differentiate the outer function first and then the inner function. For this one, the outer function is sine. We're talking about this function here. Okay. For this one, the outer function is sine. Okay. And the inner function is x raised to half. So leave the x raised to half as it is. Differentiate the outer function sine. So that becomes x raised to half. If we differentiate the outer function, it becomes cos into x raised to half. Okay. The inner function does not change, just the outer function gets differentiated, cos. And finally, the last step is to differentiate the inner function. Okay, and the derivative of the inner function is going to be x raised to and the derivative of the inner function x raised to half is going to be half into x raised to minus 3/2. Notice that this expression over here is the same as the expression over here, and thus this is your final answer. Okay, so the chain rule can be used if you have a function of a function, and you can use it. It does not matter how many functions actually are part of that chain. It could be a function, a chain of 2 functions, or a chain of 4 functions or 5 functions. In all cases, you can use the chain rule method, and it does not matter whether you want to use the substitution variable method or the single step no substitution method. In both the cases, as long as you follow the method correctly, you're going to get the same answer. Now, as a small note, let's consider, okay, the function sine of kx. Okay, we know that the derivative of the function sine of kx is k cos of kx, but we did not prove this. Now in this section, actually, you can use the chain rule to show that the derivative of sine of kx is k cos kx. How? So notice that we can use the chain rule. So we have an outer function sine, and we have an inner function k raised to x. Okay, we have an outer function sine, okay, and we have an inner function k raised to x. So the first step is going to be to differentiate the outer function, leave the inner function as it is. Okay, so if you leave the inner function as it is, okay, and you differentiate the outer function, it is going to be cos of kx. Okay, leave the inner function as it is, and then the second step is to differentiate the inner function. The inner function is kx, and if you differentiate that becomes k. If you simplify this, you get k cos kx, and this was already established back in section 6.1. And in a similar way, if you want to use the chain rule on cos kx, okay, differentiate the outer function and then differentiate the inner function. Okay, if you differentiate the outer function, you get minus sine kx, and finally you differentiate the inner function, you get k, and thus you get overall minus k sine kx. Okay, in a similar way, if you differentiate d by dx of e raised to kx, okay, you get the outer function is e, the inner function is kx. The outer function is e, the inner function is kx. If you differentiate the outer function e raised to kx, it simply becomes e raised to kx. And then you multiply the derivative of the inner function kx, and that is simply k. And this becomes k into e raised to kx. Okay, again, okay, these two were established back in section 6.1. It was established back in section 6.2. So this is nothing new. We're just trying to show that using the chain rule also you'll be getting the same answer. Okay. And finally, we have d by dx of ln of kx. Okay, the outer function is ln, the inner function is kx. So leave the inner function as it is, differentiate the outer function. The outer function ln has derivative 1 by x. So it is going to be, in this case, it is going to be 1 by kx. Okay, 1 by kx. And then the inner function has derivative k, and when you simplify this, the k and the k cancel out, leaving you with simply 1 by x. Okay, and if you remember, when we were discussing in section 6.2, we gave a word of caution. We gave a word of caution that ln of kx has derivative 1 by x, and it does not have k in it. Okay, So while most of the other ones they do have k as a coefficient, in the case of ln of kx, it does not have k in it, and you can prove it in irrespective of whether you want to break down the logarithm or if you want to use the chain rule. Either way it works out. So that's your that's the way you use the chain rule. Again, two methods possible. You can use either one as long as you can work out the entire method correctly.